Okay, so Huamin, do you want to start? Start with the PRs.
Yeah. Do you mind I share my screen?
Yeah, sure. Let me stop sharing. Yeah.
Uh, um, yeah, so I have two PRs I hopefully can get feedback on. So one is the 319. So basically, the idea is that we have a lot of capabilities in the production stack and as well as the vLLM. So if you are willing to spend more time to discuss how we can expose the advanced stuff, for example, the PD desegregation and speculative decoding, the kind of configurations, we have to go into the configuration details in the Helm chart, which is not always the easiest way. The second thing is that if you are creating different routing capabilities based on the vLLM configurations for different SLAs, like you have the conversation here. So the use case is that um, if you are willing to creating different capabilities with different VLL configurations, the current Helm chart is not able to get us over there. So the whole idea is that we expose the configuration of the VLM to match up with the routing preferences in different capabilities. So that if you are willing to use the prefill decoding desegregation in a more sophisticated setup, and then you can achieve higher SLA, then we expose such configurations to the front end. So the front end will know this is the higher priority routes, and then you can use that routes for more advanced SLA configurations. If you are using, for example, the speculative decoding, and you have pretty much good ideas that the traffic can be the speculative decoding will helpful for certain type of traffic. Then we can route certain traffics on that configuration, that kind of models to match up with the underlying GPU reusable GPU resources. So in that way, we can get the matching between the configuration and advertised routing um, advantages. So that is the whole idea that we want to achieve. The current frameworks under for example, the sorry, the Kubernetes API gateway inference extension give you certain capabilities. For example, you can use it for endpoint picker based on different models and different LoRa adapters. But that does not give us the visibility of how the GPU are being configured in the VM backend. Specifically, if you have a more um, if you have low latency configurations, uh, by looking at just the CPU metrics or request queue, you are not able to get that heuristics in scheduling. So in order to dedicate the routing preferences based on the configuration, I think it's time to expose the orchestration layer all the way to the API, the routing API. So the API, we are using that information to advertise its route capabilities and then create such a route based on requests. So I'm just going to the diagram. Sorry, I have right. So the new API will consist of the three CRs, the the inference gateway, which will define the routing policies as well as the route that will be used in the backend. At the moment, its inference gateway is implemented as its own CR, but it does not have to be in that case. If you are going to use in some other frameworks, maybe you can also adopt more well-established CRs like the gateway classes that is already defined in gateway API. Similarly, when we use the inference reference, this could be reconciled in different implementations. The idea is that when we have the inference services, we want to contain information about um, the ROS preferences and the ROS capabilities. The preferences will be which kind of a cache configuration you want to have, and whether you want to have certain NLP filters attached to that route. So we have some of the semantics caching and prompt guard capabilities already supported in the router, and we can use that for the NLP filter. So before you go into the vLLM backend, information will be pre-filtered in that way. You can have you can have your reusable cache from the for example the Redis instead of going to the vLLM to try the same query again. If you are running some of the enterprise applications and you have sensitive information, then you can use in the prompt guard to prevent the private information going to the public route. So that is one of the things that's attached to the inference services. And once we are going to the detailed configuration of the LLMs, many of the cache-related configurations can be specified here. So we can specify what's for example, the LLM cache, if you have certain transfer policies based on his ratio and threshold ratio, then you can set this up here. And by using this information, that's we can, when the controller creates the vLLM or the cache in the background, it can use these heuristics to create a related configuration. And then you can also specify the speculative decoding as well as the prefill decoding disaggregations using some of the API abstractions. The controller we are using that heuristics to configure vLLMs in such a way that will respect the configuration. For example, you should having the part prefill and decoding part sit in the same topology, and also you want to have using the models that you specified here. Um, Once the controller finishes job, is will just update the part information in the status, in the CR status. So you can use that information to understand if the part is created correctly, and you can do further inspection to check to verify that these parts are actually have this desired resources and located in the topology that's specified in the CI itself. So the eventual controller will work in such a way that will interconnect the gateway, the inference services, and using that for get the routing strategy heuristics. And for the inference service, we want to set up the inferences, basically just creating vLLM deployment. But based on the inference cache configuration, you set it up to take advantage of the advanced configurations for lower latencies and higher throughput, which will, at the end of the day, take more resources. So the relationship between the three PRs is like the inference service will reference one or more, sorry, the inference gateway will reference one or more services, and each of the services will contain at least, potentially, if you want to have advanced configurations, contains at least one inference cache configuration, and with that cache configuration, we can further identify what kind of vLLM deployments you want to start up with, and using that information to create the vLLM itself. Once the vLLM is created, then you attach the vLLM service to the backend references. And from there, you create the complete networking route from the gateway all the way to the vLLM service. Um, so that is one of the examples with two inference services referenced by the gateway. So in this way, I hypothetically assume that you could have two cache configurations, which may not be happening in reality. So you could potentially have a P disaggregation, but you may not have a speculative decoding. So this is potentially um, one or the other. May not be necessarily one with the other, but I just put it here for illustration. All right, so that's the whole idea of this new CR proposal. I can hopefully can stand up a POC in the near future, so we can just explain how the flow will work. But I hopefully can get more feedback. How do you feel like exposing the low-level details that has already been implemented in the help charts? in the controller, and then let the end users to choose what they want to configure for their gateway, for their routes. So this is some of the things that I feel that some other projects also trying to achieve, but not at the level that can be explicitly specified as this new CRs. So a little bit related to that is the gateway extension. Uh, Okay. So the Envoy AI, Envoy external processor is a little bit related to that topic. It's because when we are using the whole new CR is designed for the in-cluster use case, meaning that the Kubernetes cluster manages both the application as well as the vLLM backend. But this may not be the only use case. If you are willing to use it for ingress or egress kind of scenario, in many of those setups, we need um, Envoy proxy. So if we are going to support the in-cluster as well as the egress and ingress use case, we are going to use the Envoy proxy to achieve that. So the Envoy proxy has two modes. One is the Watson filter. The other one is external processor. So the PI is to experiment with a Python implementation of Envoy cluster, so Envoy proxy integration with the router. So as you already know, the router consists of the router library as well as the front end. The current front end is a fast API, so we can potentially post another front end. In this PR, I just put Envoy as yet another front end to integrate with the router library. And from there, that we are able to implement some of the Envoy gRPC capabilities to router. So this is a very POC kind of stage. I have not fully tested it yet. So if we are going to support ingress and egress use cases, I will put more efforts on this PR as well. But if you already have any experience with Envoy proxy integration, I would be more than happy to work with you to make it work in the right way. All right. So that's not take too much time on the first PR. So the second PR is about the. So I look at the roadmap that's Yuhua and you put out earlier, and I think the top priorities for the second quarter of this year is on the performance side. Um, so I previously, I had some of the ideas about the Python because of the global interpreter log in many cases, become the bottleneck for multi-threaded applications. So by using a different implementation based on Granule, we can go away with the GL lock and using more native multi-threading support. So I experimented with Granule as a different front end, and I think it's at least at this point it's working on my side, but I'm not able to get the performance numbers. So if anybody has a chance to have a setup to validate compare the Granule versus Fast API, that would be great. So I have a quick demo so you can take a look. If that's something that can really work and get the nice numbers, I would recommend to go, because this PR does not change any of the existing code. I I would love to have this one in experimental stage, and hopefully we can get it put it in the fast forward to improve the performance.
Great, great.
Right?
Uh, I think just one thing, we are also like working on like benchmarking the router's performance, and I think this will be very helpful, and we're thinking about also like testing this.
Mhm.
Okay. Thank you.
Thank you. Yeah, thanks, Huamin, for the very detailed proposals for both the controllers and the Granian backend. Yeah, any questions from the audience or comment?
I have one question around the inference gateway. Are you using the same same thing as the upstream, Kubernetes upstream, or this is like completely new controller, or
It's a new controller, new CRD and a new controller. But we do have a conversation with the the Kubernetes Gateway API team to see if that is something we can work together to define the API as well as the controller, so we can make it more reusable and generic.
yeah, because they are also working on, I mean, as a part of working group serving, they are working on creating an inference gateway, which I
Yeah,
don't know if it has all the features that you have enlisted here, but the name is similar and it is
I
also,
agree. It's a kind of let's say there's a similar effort. I like to put this way. So the Kubernetes API gateway inference gateway extension is very focused on the use case of the routing itself. It does not go into the details of orchestration, meaning that it does not create the vLLM backend or any of the advanced configurations. So it has limited visibility about what's the performance numbers it can get from the backend. So if you're looking at the front end routing policies, it can go as far as the endpoint picker based on the GPU stats at the queue length. That is very limited heuristics you can use. Versus the new API I'm proposing is actually expose the configuration upfront to the in the CR, so you know what kind of backends we are creating, and you have good ideas how to use in the GPU metrics or the vLLM configuration to identify what is the best situation for that route. So there's a certain level of granularity and visibility you can see in the CR. So that's why I believe this is complementary to the Gateway API. So if that becomes something useful for the serving work group, we would love to go away to to that audience and propose such collaboration.
yeah, no, that's what I was suggesting. Like, if this is like more comprehensive compared to what they have, it would benefit the wider Kubernetes
Yeah,
community if this gets accepted there, like with all the features that you're suggesting, and production stack might as well just include it, you know.
yeah. We can go that well. So yeah, so I think the working group really want to have something that can be validated. The early concepts can be easily consumed because they're easy to understand. The heuristics are not complicated to get. But this one a little bit different because we have to make sure that the configuration once the CR is created will have long durations, meaning that if there's new inference engine or new kind of configuration that will come up to life, we do not have to change the CR or change the controller extensively to support this new inference engine or new capabilities. I think we have to do some of the POC to prove the point first before we can go all the way to the working serving group, the serving working group in Kubernetes.
Right, cool.
But
Yeah,
I love that idea. So if you are interested in collaboration, just feel free to comment on the PR and any of the follow-ups, we will just add you to the conversation.
sounds good. Yeah, thanks.
Thanks. Okay, any other questions or comments? Okay, if not, like we can move to the next item. Yihua, do you?
Yeah. So hey, just wanted to give everyone a quick update about the disaggregated preview support. So right now there are like two things. One thing is about the using the already existing disaggregated preview in vLLM v0, and what we are going to do is at first we are trying to like by modifying the current count chart to provide the user interface to directly like let the user set up the distributed preview very easy. And the by default, I think we're going to run something like the provide some option to let users to run like the default connector in vLLM or the M cache connector. And the next step is we can like as Kwame mentioned, we're in his like CRD design, there is already something about the disaggregated prefills CRs. So I think once that API definition is ready, we can move to the CRD and controller-based deployment of the disaggregated prefill. So yeah, and then we're in the meantime, our team is also actively like working with the vLLM team on the vLLM's V1 disaggregated prefill support. So we are trying to pushing the push forward the vLLMs, the connector interface, disaggregated prefill connector interface in vLLM V1, and trying to implement also a Mcache connector for it. So in the near future, maybe in the I think if I remember correctly, the timeline is like around by the end of like April, we should have a working solution in upstream view and V1's implementation for this. Yeah. So that's the thing about the distributed prefill, and also we are going to support it in the production stack.
Thanks. Yeah, any if there is any quick questions to this part. Okay, I think we are out of time. And so thanks everyone for coming and thanks everyone for your input. Yeah, so next week we'll meet on 8 a.m. Next Tuesday at 8 a.m. PT. Yeah, so yeah, I'll send a reminder then. Okay, thanks everyone for coming. Bye.
Thanks, folks.
Bye.
Bye.
Thank you. Bye.
Bye.
Thank you.
Thank you.